Okay. All right, 7th graders. So yesterday we left off where you had compared your models with some other people, and then several students came up to the front of the class and put their thing under the Elmo and presented their models to us. And so what we want to do is see if we can capture. Remember with the thermal energy sort of capture, like what are we initially thinking and agreeing on? We're going to see if we can capture that right here. Some of the similarities, differences, and places where we have some questions. Okay, so let's start. Let me start with one potential difference, which was, did everybody represent the same plant? No. So we had I saw we had a blueberry, we had an apple,
had a banana.
I had a banana.
And a maple tree.
So when we're doing models, we often do something that's sort of like a more a generalization, so that we can apply it to a bunch of different things. So how could we represent just like a plant? Like what can we draw up here just to be like, it represents all plants, whether it's a bush or just a branch
Of something.
maybe a branch.
Yeah, maybe a branch, and then maybe a root.
Liz had just like the roots and the stem part above the ground, trunks and whatever. And
Did everybody have roots and stems
I was
though? Did
thinking
everybody have a
that's
trunk?
something that a lot of people
Yeah.
had.
So
I
it's,
saw.
but do blueberries come from a tree?
Well,
A
we
bush.
could think if we could,
because we have apple trees. Like I guessed on what I thought a banana tree looked like, but I know what an apple tree looks like. Whatever, so I would feel more like I can picture an apple tree.
Sure.
Around that.
So one thing I'm wondering, because I know we did this with thermal energy, sometimes we would just use a random shape to say this is the thing, like a box or like a circle or something. So could we just be here's our plant, whether it's an apple tree or whatever, this is our blueberry bush, this is our banana tree. Can we just sort of, because with our models, a lot of times they're simplifications of the real thing, so that we can just sort of see the important parts. So we're going to sort of say this is our plant.
So does that include the roots, or do you want to?
Well, let's talk about that. Did people have roots?
yes.
Is that something that was common to all models? So I hear a few things. I hear that Des was representing those atoms that we saw in our food molecules. She was saying what this stuff is made of. But so what did you say water is made of?
So first I took from the very beginning, I did a banana. And I said bananas consist of carbs and proteins. I broke down the carbs to the atoms, so carbon, oxygen, nitrogen. For proteins, I did carbon, oxygen, hydrogen, nitrogen, and sulfur. So I was trying to figure out where they're found in the world. So water or the rain is hydrogen and oxygen. And then the air consists of carbon, oxygen, and then I remember, I think it was nitrogen. And I think too much nitrogen is bad. But I think nitrogen is in the air. And then I remember that I went to Florida, and Florida has really stinky water. And they told me that their stinky water was because of sulfur. And so when I went through all of the water and the air, I actually found all the molecules that makes up carbs and proteins.
What do you guys think about it? Do people understand what Des is saying?
Yes.
You should have took a picture.
If you're not sure,
No, but
you might want to ask Des a question, or maybe you have an idea of your own.
somebody said maybe it was Chuck something about Lego. So is it is the idea that all of these pieces, these carbons and oxygens, all of these pieces are coming from maybe different places, but then getting put together? That either the recipe or the plant build.
You could have one thing, and then you could take it apart and make other things out
Like
of it.
Lego.
Oh yeah. So let's continue. So I've got this idea, are we building these, or are we making these? Is it like Legos that we're putting the pieces together?
Yeah.
Des has brought up this idea that she thinks that somehow the carbon, the hydrogen, and the oxygen and the other stuff is coming into the plant. And what we're trying to figure out is what do we have in common for what these possible goods could be? So far we've got water and we've got sun. What else do we have going in that was similar?
I said air.
And air? Do other people have air?
I didn't put air, but it makes sense because we're
But
all
I
around.
like that answer.
But
Is
remember,
air going?
I like
Air's going into the plant. How's it getting in there?
It's all
I like it.
I'm hearing a lot from these three. Anybody else have? What's your response to how air is going in there? Did anybody else think of air?
Well, yeah, that's when I think of thermal energy. When we talk about how things can get in somewhere and we can't picture it, it's because when we talk about thermal energy, that the ones out here bump into each other and they kind of send the energy through. So like, could it be something similar like that, or like they, like we're not actually having like air like doesn't go through our cup, but like the energy around it like was bumping, and then that passes the energy through because they bump each other.
What is
Sure.
air?
Yeah, what is it? We got some, can you write that down?
I
So that we
did,
get-
that was my question I wrote down. What does air add to the bottom?
So we have some ideas that maybe air is going in here, but maybe it's like from that thermal energy where they're bumping.
Like a chain reaction kind of.
Or do you have
Oh,
a different idea, Chuck?